the Xbox velocity architecture, particularly sampler feedback streaming, is a game changer, even in light of the PS5's brute force SSD. So in this video, we'll be talking about why that is the case. Remember to like this content, subscribe to the channel, and leave a comment if you enjoyed this. So, to understand what we're talking about, if you did not watch my Xbox velocity architecture video, you can go up and see the previous videos that I recorded this week. I have an in-depth look at the velocity architecture in an easy to understand, summarized way. In this video, we'll be talking especially about sampler feedback streaming and why it's a game changer. So, the PS5's SSD is quite fast, 9 gigabytes per second of compressed data, 5.5 gigs per second of uncompressed data. So it's a game changer in I/O speeds. Basically, it's very, very fast. But Microsoft has decided to go with a 2.4 gigabytes SSD, which is no slouch, by the way. 2.4 gigs per second is much faster than the 60 MBs per second in the Xbox One or the PS4. Now, of course, the PS5 has the advantage with the raw SSD. 5.5 is bigger than 2.4 and 9 is bigger than 4.8. However way you look at it. So in this video, I'm talking about why Xbox velocity architecture as a whole, not just the SSD as a whole, why this is actually something we should not forget about. So for us to understand why Xbox velocity architecture is a big deal, we need to realize that, as mentioned in the earlier video, the velocity architecture is not just the SSD. The velocity architecture is actually made up of 4 components: the SSD itself, the decompression blocks, sampler feedback streaming, and direct storage. So these 4 components together are what make up the velocity architecture. And I think that when they are combined, they actually can rival the PS5's I/O. They can rival that 9 gigabytes per second. This is because with the Xbox velocity architecture, particularly when talking about the sampler feedback streaming, we have a whole lot of optimizations that make it easy and more efficient for the GPU to use memory. With the PS5, everything that's being loaded in memory is being loaded the way the games traditionally load any assets, really. But with velocity architecture, particularly sampler feedback streaming, we definitely have a difference. So for us to understand this, we need to understand the concept of MIP maps. So in computer graphics, MIP maps, or even pyramids, are pre-calculated, optimized sequence of images. For every 3D model, your GPU actually creates a 2D image of it, and then it stores all the sides of the image and creates multiple versions of that image from high resolution to low resolution. So if you've got a 4K asset, you have 4K textures, and then they'll be downgraded. You have different copies that will be downgraded all the way to the lowest level. This is because depending on depending on where you are in the game, depending on what you are doing, some things might be up close and others might be further away. So the things that are up close need to be loaded with the highest amount of detail. So it's basically going to pick up the MIP map that has the highest level of detail, LOD as it is called in graphics and DirectX. So if you are further away, you don't need to load the high resolution texture, you just need to load the lower resolution texture. So when picking the MIP, basically your GPU is going to pick the smallest one to save on the amount of CPU and GPU cycles as it renders the scene. If we only had high resolution textures instead of just using a set of MIPS like this, it would be very performance heavy, and in reality the way the image would look would be very sparkled. It would look, because of too much detail in the scene. The things that are very far away would be very detailed. It would look like a pixelated picture. So because of this, you need to load the smaller MIPS, the smaller textures. So now what you need to understand is, for every asset there's several MIPS, right? There's several MIPS, or several versions of the same thing. So if you have a tree, you've got the high resolution tree, a less if we start from the very highest, we can say you have a 4K texture, then maybe you have a 2K texture, then you have a 1080p texture, then you have a 720p texture, then you have a 480p texture, then you have a 360p texture, a 144p texture, and so on, right? So for every single object on the screen, you have several versions, and this is me trying to simplify it based off of what was discussed on DirectX Developer Day. So because of that, for every single thing that you load on the scene, you're actually loading all of the MIPS. So if you've got 10 MIPS for a tree, then in memory you actually are going to store all the 12 trees, from the low resolution one to the high resolution one. And this is actually where sampler feedback streaming has become a game changer, in my opinion. So the PlayStation 5 does not have sampler feedback streaming, and it has a faster SSD. So in that case, it's definitely going to load all of the 12 or all of the textures, all of the MIPS for that single object. Now on your scene, when you're playing a game, you could have so many objects, right? The floor, the ground, the walls, the player himself, whatever is holding, everything that's in the particular game scene. And for every single one of them, you have the high resolution and all the way down to the lowest resolution. Why? So that as you move away from them, they will be swapped, right? On the screen, it's going to display the one that's needed depending on how far or how close you are to the camera. Again, the further away that object is, the lower the resolution it's going to be. So it's going to load the lower MIP. Now, as you can imagine, because you have to store all of these MIPS at once, you have to store all of these MIPS in memory, even though you're only using one at that moment. This causes performance problems, particularly in the aspect of storing these MIPS. You use more memory on the GPU, you use more memory than you should, because you're only loading one thing. If it's very close to the camera, you load the highest resolution one, but in memory you have still stored the lowest resolution one, even if you've only rendered the high resolution one. And if it's further away, you've loaded all of the textures, all the MIPS to all the quality settings, even though in reality on the screen you're only rendering the low resolution one. So with sampler feedback streaming, this is basically what this avoids. With sampler feedback streaming, you only load the MIPS that are needed to be rendered at runtime. You only render the things that are needed. So you're not going to store all the MIPS, you're going to store the MIP that is needed on the screen at that point. So this means that you're not going to really have a lot of wastage with the memory, right? You're not going to have so many things stored at once waiting to be used, okay? Because of that, you save more memory bandwidth. This is why in the other video I did mention that this can result in an effect where a GPU with much less RAM, right? I'm assuming the Xbox Series S is able to compete with a device that has much more RAM, and a device with low RAM is able to basically be able to store as much as the one with more RAM, simply because the one with less RAM is using sampler feedback streaming and is only loading the assets that are needed at runtime, the ones that are needed to render on the screen, while the one with higher RAM is going to load everything, including the MIPS that are not needed on the screen at that time. So to help give you a visual cue, shout out to Gavin Stevens on Twitter for his simplified explanation of this. But I've included an image in the video which shows the different textures: 512 by 512, 256 by 256, all the way to 64 by 64, right? Which is an example of what a scene would look like. So for all the textures in the scene, you would have to actually store all of these MIPs. The different images you're seeing, that's what we mean by a MIP. So you would store all of these in memory, right? And then if I'm close, I would load the 512 by 512 because I need to see the full details, so I need the highest resolution one. And if I'm further away, I would load the 64 by 64, right? So that's the idea. Now, the problem is with traditional systems, with traditional game engines, with traditional game developers, you're basically going to be storing all of those textures regardless of how far or how close you are to the screen. So if I'm very close, even though I'm loading the highest resolution texture on the screen, I am still going to store the low resolution one. And if I am further away at the back, I am going to load on the screen. I will render the low resolution one, but in memory the GPU would have stored the high resolution texture either way, and this is where the memory wasting comes into play. So because of this, the GPU is actually going to be having lots of RAM used by MIPS that are not actually being rendered on the screen. And this is why sampler feedback streaming is important, because in sampler feedback streaming, if the character is further away, only the low resolution MIP will be loaded. The high resolution MIP is also only going to be loaded without loading any other lower resolution MIPS. This is actually what we mean by saving a lot of data. And this is a big feature because with 4K gaming, 1440p, 2K, right? All of those things, we have large game files and we have high resolution textures. So the way the memory is going to be used is a big deal. Now, based off of this analogy, you can clearly understand and see the benefits of sampler feedback streaming, because in sampler feedback streaming, you don't load in as much texture data for every single asset as you would in the traditional. This is why I'm saying Xbox Velocity architecture, especially when we consider sampler feedback streaming, this is basically a game changer in the way the memory is going to be used. And this could result in Microsoft's terms, they're saying 2.5 times better memory usage, which is definitely something that we should not overlook. So yes, quite alright, the PS5 has got the faster SSD, and no one is arguing that, right? It can load 9 gigs of data per second, but if that 9 gigs of data is basically copies of the same character, right? The low resolution MIPS and the high resolution MIPS and everything in between, then it's still filling up the 9 gig with things that are not being used. But with sampler feedback on Xbox One X, on Xbox Series X rather, if even with 2.4 gigs per second, which is slower than the 5.5 on the PS5, we are only going to be loading the necessary MIPS. We are not going to be loading MIPS that are not going to be used in memory. So yes, the drive is slower technically, but it's also not loading in as much things as the PS5 is going to be loading, because it's going to only load the things being rendered on the screen. This is why Microsoft was saying that with the Xbox One X, their analysis was able to show that for games running on Xbox One X in 4K, 66% of all the assets that were loaded in the GPU's memory were not even used, right? They were not rendered on the screen. 66%, can you imagine that? 66% of all the things in the RAM were not actually even used. Remember, the point of RAM, or the point of memory, is to be able to keep the things that should be further passed to the GPU or to the CPU. So in this case, 66% of everything that was sent to the RAM was not actually sent to the GPU or the CPU to actually be rendered on the screen. This is because every single character, as mentioned, had several copies of high and lower resolution MIPS that might not have been used at all. So with the Series X, this is not going to be a problem. We will only render to the screen the things that need to be displayed. So for a single character, we don't need to load all the different versions, the 1080p, the 2K, the 4K version. We only need to render the one that we need to display at that point. I hope this gives you an idea as to why the Series X sampler feedback streaming and why velocity architecture as a whole has some really good improvements that are not quite easy to quantify. The PS5's SSD is easy to quantify. We can easily say 9 gigs per second is good. Yes, those are really good numbers, but something like sampler feedback is difficult to quantify. The only real hard numbers are the fact that around 66% of everything that's going in the memory of an Xbox One X system is actually not being sent to the GPU, which means that we're wasting 66% of the memory, right? And from Microsoft's approximations, 2.5 times is the performance or the memory usage efficiencies if we do use sampler feedback streaming, such that we limit the amount of stuff going to the RAM. So what do you think about this video? Leave a like, subscribe, leave a comment if you have questions, but that's basically why the velocity architecture as a whole, right, the SSD, the decompression, the direct storage, and sampler feedback, why they can actually have a significant impact and actually match, maybe even beat the PS5's raw speeds, simply because we don't need to load as much data as the PS5 has to. That's the reason. So thanks for watching this video.